Hello guys, welcome back to the next video in our OrCAD X keyboard series. My name is Adam, and in this video we are going to be creating the circuit for the LEDs on our keyboard. One thing I forgot to do at the end of last video is that we do actually want to take all of these row and column off-page markers and put them on our controller page, because ultimately these do need to connect to our microcontroller. Now, specifically for all of these connections, I actually recommend just kind of connecting them anywhere for now, and then worry about finding the right configuration of, which pin is going to be a row, which pin is going to be a column, and respectively which pin is going to be an input, which pin is going to be an output. And the reason for that is once we actually connect all of our matrix on our PCB, you'll notice that there is quite a lot of connections. And it's easier if we can unravel them on the schematic rather than trying to plop down a bunch of vias and connect them all that way. So all I'm going to do here is just copy these columns now, Control C, go back to our controller page, paste these. We want to rotate each of these and then place them on our microcontroller. So I'm just going to grab a couple at a time. Oops. And then let's go ahead and connect them. And we can speed through this also in the video. All right, there we go. So we have our rows 0 through 5, columns 0 through 18. And I'm just going to go ahead and give them a little bit more space on here. Oops, so we lost a wire there. And then what we'll do is once we get to the actual PCB layout, we might rearrange these just to make our life a little easier. Or we might even show you how pin swapping works. All right, so the next thing we want to do is actually use one of these GPIO pins in order to output to an LED signal. Now let me just look at my reference here. So let's go to our LEDs page. And if I go in my Component Explorer, I want this part called SKC6812. SKC6812. So this is a Neopixel. Again, we're creating a keyboard. It's very mainstream. Neopixels also happen to be very mainstream. Let's go ahead and just place this on our schematic. And this is going to be on our LEDs page. I click place. And the special thing about Neopixels is that they're actually, so they are a tricolor LED, or actually in this case it's 4 colors because you get RGB and white. The special thing about them is that they have a power pin, a ground pin, a D in pin, which is data in pin, and then also a D out pin, or data out. So I'm going to mirror this. And what that means is we can drive a chain of these LEDs together from a single data pin, and all that data will tell how each LED should behave, right? What color it should be producing. Should it be dim? Should it be bright? That's all controlled through the data. So we'll input the data through the data in pin, output the data through the data out pin, and then essentially connect the data out of the first LED to the data in of the next LED. For this keyboard, I think we're going to have a total of, let's see, 1, 2, 3, 4, 5, 6, 12, 13, 14, 15, 16 of these. So let's go ahead and connect that. We're going to have a data in signal, and then let's add a net alias, call it LED data. And this will be coming from our controller. So let's go ahead and place a symbol here. This is going to be our LED underscore data. Oops, let's copy that from here. Control C, go to LEDs, and there's our LED data. Now our ground is also going to be coming from one of these symbols. So paste it in here. And then we have our VDD and our DOUT. So VDD is actually going to be from our 5-volt source, which is USB in this case. And we'll talk about how we convert the LED data into, from the 0 to 3.3 volt logic that we get from the microcontroller to the 0.0 to 5 volt logic that the Neopixel actually expects. We'll talk about that in just a second. So let's go to our power page, grab this 5-volt net. I'm going to place it up here because we also need to add a decoupling capacitor. So let's search for our capacitors and add a 0.1 microfarad right there. And let's just extend that just a little bit. There we go. All right, so we should be able to then take this kind of blueprint minus this net here, and let's see if we can just copy paste it. What did I say? 16 times? 3, 6, 9, 12 plus 4 is 16. Yep. So 1, 2, 3, 4, 5. And then let's get just a little more space here. 6. And this guy, rather than going over there, is going to come around. So let's line these up here. There we go. So this is going into our DIN. So we got 6, so that's 7, 8, 9, 10, 11, 12, and then same thing here. This is going to come around into our next row. And 13, 14, 15, 16. There we go. So just connect that up here. And now we have our 16 LEDs with, this is going to be our last one, so it doesn't actually need anything on the DOUT pin, so we can place a no connect. Now the only thing that we need to worry about here is that, as I said, the Neopixel expects a 0 to 5 volt logic signal, but our microcontroller is only able to output 0 to 3.3 volts. Now the way to remedy that is we can use what's called a logic level shifter. And because we already have a 5 volt source and a 3.3 volt source, this is really super easy, right? We don't need to boost our power. We don't need to grab it from another connector. All we need to do is add that logic level shifter, and we can do that by using a transistor circuit. So one thing I'm going to do is I'll leave this LED data here for a second. I'm actually going to, how do I want to do this? Let's copy one of these guys. Oops, we want to copy, not cut. So we're going to shift everything just by 1. Why do I keep doing cut here instead of copy? I don't know. So we're going to do also this pin here. So Control C, Control V. Then we're going to delete this first LED here, and this will become our first data in. This will become our last. So we're still at 16. Let's place the no connect right there. All right, so this LED data is what we need to convert from 0 to 3.3. So let's break this connection here. We need to convert this 3.3 volt signal into a 5.0 signal, or 3.3 volt logic to 5 volt logic signal. And we're going to do that, like I said, with a with a MOSFET logic level shifter. Now, in order to demonstrate how that works, I've actually set up a simple PSpice simulation inside of OrCAD. If you weren't already aware, you can actually run PSpice simulation in OrCAD. It's really easy to do. You just start a new project, file, new project, and enable PSpice simulation. But in this project, what I've done is I've simulated the circuit, which is a MOSFET configured in such a way that this the source pin is connected to our low voltage signal, and the drain pin is connected to our high voltage signal. Now each of these are also pulled up to that voltage source, so 3.3 volts here, through a resistor. In this case I'm using a 10K ohm. And on the drain side here, you can see that we have the drain D through a 10K ohm and our 5 volt supply. Now this 3.3 volt supply would be coming off of our regulator. This 5 volt supply would be coming off of our USB. And then I have a pulse signal simulated here, right? So a data pulse and a 1 mega ohm resistor here that's going to simulate our load. And then we're just going to see how that looks on the output. So once you run the simulation, this is essentially what you get. Let me just trace property. If I change the color here really quick, it'll be easier to see on top of the signal. So our low voltage signal is this teal color here. You can see that it goes from 0 to 3.3 volts. It's a nice square wave. And then our high voltage signal, you can see on the output here, this is where we're probing it, is going from 0 volts to 5 volts. Pretty much exactly what we need. Now it does sometimes dip here towards the negative. How far that dips is really going to depend a lot on the MOSFET that you choose, the parasitics in your circuit. But in this case, it really won't have much of a problem. All right, so let's get back into our LEDs page here. I do have a transistor which I can use. I believe it's in my, is it in the switches? Oh, I have a transistor right here. There we go. And this is a MOSFET, an N-channel MOSFET. So we're going to grab that, place it right there. And then we want, as I showed in the PSpice simulation, let's just go back here. We want a pull up to 3.3 volts on the source side, a pull up to 5 volts on our drain side, and then the gate is actually connected to our low voltage supply. So let's grab a resistor. 10K should be just fine. So we need one here, and then we need this 5 volt source, and we need our 3.3 volt source, which we can grab from our power page. And then we can just go ahead and connect this up, just like we had in our simulation. And there we go. Oh, not this wire here. I definitely don't want that. Perfect. So this simple transistor circuit should essentially convert our LED data from 3.3 volt logic into 5 volt logic. And we should expect to have, the data going into this, what is it called? A Neopixel LED. And then the data coming out from the Neopixel will already be in that 0 to 5 volt range. And then it can just continue to daisy chain down from each LED to the next one. We're pretty much good to go. So we're going to be able to flash these, create some really cool colors, make it dim, make it go brighter, maybe make it blink. Yeah, we'll use our imagination once we get there. But that's it for this video. The last part of this video is going to be covering the LCD, which is again an I2C IO expander, and then also the actual LCD module. So we're going to be just connecting all that up really quick. And then I think we'll be ready for layout. Aside from this little warning that I see here, so the number of pins on SOIC 8 instance does not match U2. So I'll actually go ahead and fix that in the background outside of the video. Looks like I'm just probably using the wrong footprint for this. But yeah, see you guys in the next video where we will cover the hookup for the LCD. And yeah, that's it. If you have any questions or comments, please leave them below. If you have any advice or if you have any recommendations for future videos, please let us know as well. And yeah, thank you for watching, and I'll see you in the next video.